Okay, let's give you guys another example. So we're going to try and sketch this graph in polar form. When you first look at this, something you should notice is that this here is symmetrical along the x-axis, because if you put in a negative version of this thing here, if you put in the negative version of the angle, so it's like this, um, yeah, then this thing here is cos theta, cos theta. So when you put in the negative version of the angle, when you put in the negative version of the angle, this whole thing here remains the same. It is the same thing. So you know it's symmetrical along the x-axis. And something that you should spot straight away is that if you put in the negative version of the radius, so it's like this, minus r squared, then the whole thing here will be itself, because minus r squared will be r squared. So when you put in the negative version of the radius, then the whole thing will remain the same, meaning it's symmetrical along the origin. Well, remember, symmetrical along the origin means this. Let's say this distance here is, the radius is 5, then it's negative 5. So being symmetrical along the origin is anything along here will be exactly the same over here. So looking at this, you should be able to spot that it's symmetrical along the x-axis and it's symmetrical along the origin. Okay, so now look from here. Sketch a graph of r squared versus theta. Remember, r squared, not r. So when you sketch a graph of r squared versus theta, then it will look like this. Now, once you're here you've got r squared equals this thing here. Once you're here, you've got to ask yourself, what is the radius? Well, the radius will be the square root of this thing here. The radius. So when you are here, you've got to ask yourself, what is the radius? The radius would be the square root of this thing here, meaning that this thing here will be meaningless when it's negative. So when you are here, we can pretty much ignore. It would be meaningless to have a square root of a negative number. So your domain is really here, but not here. But rather than saying your domain's from here to here and then having a gap from here to here, rather than doing that, let's just say our domain will be from here to here. So rather than saying, rather than working from here to here and then having a gap and then from here to here, rather than having that, just say let's work from negative pi over 2 to positive pi over 2. So your r squared will look, your r squared will look like this, but ignore these here. Okay, so let's just work from negative pi over 2 to positive pi over 2. So this here is r squared. Well, r squared is that. So if you look at this, hang on. At the moment, you've got r squared looking like this. Now you ultimately want to know the radius. You want to know r without the squared. So looking at this hump here, when you square root this hump, this 4 here will be 2, because the square root of 4 will be square root of 4 will be a 2. If you square, and then if you look at this here, square root of 0. So r squared here is 0 square, but because you're interested in r, not so we are currently at r squared. We are interested in getting to r. Well, square root of 4 will be 2. This here, r squared is 0 here, so r will also be 0. Here, r will also be 0. R squared having this hump here, the square root will also be a hump. It will also be a hump. So what I'm trying to say is that if you have a hump here, if you have a hump, the square root of that hump will also be a hump. If you get a graph plotter and plot it, it will look like this. So the red line here, the red line represents 4 cos theta, meaning r squared. The red line represents r squared. Well, if you square root the r squared, if you square root this hump, it will give you this blue line here. So when you have a hump and then you square root a hump, you're also going to get a hump as well. You're going to get a hump. So so the red line represents r squared. The blue line represents r. Now we've got a graph where now we've got a graph of r versus theta. So this graph here is r here versus theta. So now we are looking at the blue line here. But don't forget, earlier we were r squared equals 4 cos theta. So really r is the positive and negative version of the square root. So what I'm trying to say is, hang on. What I'm trying to say is that don't forget there's a negative version of this blue line here. Okay, but let's just concentrate on this for the time being. So now we've got r and we've got theta looking at the blue line here. So now we can sketch our graph now. So when theta is 0, so when theta is 0, the radius will be 2. So it will be this point here. So we are working our way around to pi over 2. So we are working our way around to pi over 2. So so originally when theta is 0, we would start here. The radius would be 2. So looking at this here, as you move to pi over 2, the radius will be 0. It will get to 0. And don't forget, around here, the steepness around here is a lot steeper than around here. So as you move around to pi over 2, your graph will look something like this. Remember, you start here. By the time you get to pi over 2, it should be 0. The radius should be 0. So it will look something like this. Because this bit here is well, looking at this here, around this region is steep. So by the time you get to near pi over 2, near pi over 2 around here, it will be very steep. You will get to 0 very steep. Over here is a gradual decrease. Well, from 0 to pi, so from 0 to pi over 2, sorry, your graph will look like this. Okay, and don't forget it's symmetrical. It's symmetrical. Earlier we said it's symmetrical along the x-axis, and it's also symmetrical. It's symmetrical at the origin. So what that means is, if you draw a straight line across the origin, then this point here will also map to here. So what I'm trying to illustrate here is this. Hang on, bear with me. It will look something like this. Being symmetrical about the origin will look something like this. Oh, badly drawn. Sorry. This point here should be. This point here should be somewhere down here. Well, being symmetrical about the origin would look something like this. Okay, so this point here maps to this point here. Well, I hope you can follow it. So we've done from 0 to pi over 2. So we've done from 0 to pi over 2. So now we've got to move from 0 to negative pi over 2, meaning we've got to start here and move in this direction to negative pi over 2. Okay, so earlier we were here, we moved to here. Now we start here and move to here. So we are now starting from 0 and moving to negative pi over 2. While looking at the blue line, looking at the blue line, when the angle is 0, the radius will be 2. By the time we get to an angle of negative pi over 2, the radius should be 0. So the radius should be 0. So it will look something like this. It will look something like this. Bear with me. It will look something like this. It will look something like this. And then once we've done this, because it's symmetrical along the origin, then this point here will get mapped to somewhere over here. So because it's symmetrical along the origin, your graph will look something like this. So So moving from 0 to pi over 2, it would do this. And don't forget it's symmetrical, so we will automatically get this. And then moving from here to negative pi over 2, we will get this. Because it's symmetrical along the origin, we will automatically get this bit. So your graph will look something like this. If you get a graph plot on Plotter, it will give you something pretty like this. Okay?